From our home screen, we're going to go ahead and select Project Settings. As we can see in here, we do have Fabricator and Job, but we're going to start in our Design section of our job settings. So if we select Design, we can see Design Settings, we see Plate Design Settings, Moment Plate Design Settings, Flange Plate Clearances, Weld Design Settings, Seismic Weld Access Holes, Schedule of Minimums for Structural Members, Schedule of Minimums for Single Plate Shear Connections, Field Clearances, and Composite Reaction Factors. Let's start by looking at the Design Settings. Go and select that. And we can see inside of here, we can change our connection design method. We can specify here within our design method whether we want our different connection design to follow the AISC if we are using the ASD or LRFD. We have some different options. Do we want to show our imperial moment loads in kip inches or kip feet? Inside of our beam design loads, this allows us to specify how our default loads are calculated, whether we want that on a certain percentage of the uniform allowable load or the maximum web shear out of the manual. Or if we check on that minimum setup connection, that is automatically going to lower the loads until it can pass whatever we have in our setup for our minimum connection information. We can specify the percentage of the maximum allowable moment. Do we want to design it as a seismic connection? Do we want to calculate the tie-in loads? And then for our seismic moment type, do we want to use OMF, IMF, or SMF? What is our default material connection steel grades? If we're using composite design, what is our composite loads and the strength and thickness of the concrete? And then for our bracing, what is our percent of allowable tension and compression loads for our horizontal, vertical, and then intersection horizontal braces, as well as our intersection vertical braces. We have the option to pass those gusset beam interface forces to the beam, so we can pass some of the loads from the vertical braces into those beam connections. And if that is checked, what is our UFM special case design? We can specify our connection information for our wide flange vertical brace to gusset web or flange. Are we using seismic vertical brace gusset design, and with that SCBF or OCBF? And then do we want to use the AISC seismic design first edition gusset geometry? And then our minimum bolt rows for our horizontal and vertical braces. At this point, I'm going to say OK or cancel because we did not make any changes. Our plate design settings, we can specify the distance if we want to design a shared gusset or not. And then we have the option to design for a beam and column gusset if the flange ends are closer or less than. What is our multiplication factor? Do we want to design by first incrementing the plate thickness or the plate size? Do we want to round our flat plate values? Do we want to always provide transverse beam stiffeners? What is our minimum beam stiffener plate thickness? What is our total stiffener clearance? Now, if we take a look here, we can see our total stiffener clearance of 1/8 is going to be a 1/16 at the top and a 1/16 at the bottom. And then do we want to use the HSS column reinforcing plates? If that is checked, if the system requires that reinforcement plate, it will design that with the plate. If this is unchecked and the system sees that that is needed, it is just going to result in a failed connection. Next, we have our moment plate design settings. So in here is where we can go in and really specify our setup for our moment plates. For our stiffeners, do we want those coped or clipped? Do we want our quarter operation for our flange stiffener size by? What is our minimum plate thickness for the doublers, the extensions? What side of the column web is that doubler on? For our flange stiffeners, do we want those designed as needed? When needed, use full depth, or always use full depth at all connections. And then the same for designing the plate thickness by. When framing to the column web, do we want to determine the welded moment flange stiffener thickness by a dimension or a percentage. We have the option to extend the plate. And then do we want those top flanges flush top or flush bottom for the top flange and the bottom flange? And then if we want backup bars on our welded connections, we can specify what type and grade we want to use and what the sizes are below. Next we have our flange plate clearances. When we have a moment connection, what do we want our flange plate clearances at? What size of gap? Right now everything is set to be a 1/4 inch, but based off of this table you have a nominal depth, so anything less than an 18-inch deep beam is going to use that gap. Between 18 and 21 we'll use the 1/4, which everything's 1/4 like I said, and then the bottom one is anything larger than a 30-inch beam. You have the option to specify where you want that gap, whether it's at the top, bottom, or both. And then when you are using a wide flange brace, what is your horizontal brace gusset gap, as well as your vertical brace paddle plate gap, and then your maximum gap for a single filler plate. Next, we have our weld design settings. So this is where we can go in to specify all of our basic weld information, as well as our welded moment information. So we have our weld standards, the tensile strength and the electrode type. Do we want to perform chamfers? Do we want to show the weld length on the symbols? And then for our moment connections, what is our weld gap, the reentrant cut radius, root face dimension, web setback dimension, groove angle, then the alternate one, reentrant cut radius, length, depth, and then our flange flush length. And then what reentrant cut type are we using? For our cut type, is that parallel to flange or perpendicular to the web angle? And then for our weld size, what is our minimum for the job? Our maximum weld size for non-strength connections, so for like our column base plates is an example. And then our maximum field weld for our HSS braces. And then our weld pattern for our base plates, cap plates. So we want that as 2 faces, all around, all faces, or all faces with a seal. And if we're using a seal weld, what is that seal weld size? The next thing we're going to take a look at is our seismic weld access holes. If we take a look, this is going to be number 1, this is number 2, this value is number 3, this value is number 4, and this value is number 5. And then we can specify our web setback based on the hole type, our weld gap, and the root face dimension. Now you can specify what access hole type is being used in your shapes file. We're going to skip over our schedule of minimums for our structural members and our single plate shear connections, as we will cover those in a later video. And we'll look at our field clearances. So for our non-auto standard connections, we can specify our field clearances for our shear plates, tees, our clip angles on supporting or supported, our bent plates, end plates, seats, splices, or plain end. For our brace connections, when it's braced to another member or braced to a gusset. For our joist connections, when it's a plain end and bearing, whether it's a seated connection, bottom cord extension, or knife plate. For our welded connection, we can specify when it's a brace to a supporting member or a brace to brace. For our end plate field clearances, do we want to round that end plate field clearance or not? And then our steel to concrete connections. What is our end and pocket clearance, as well as our pocket grout thickness? So again, these are going to apply for non-auto standard connections. When we get into our connections, we'll explain how to set these field clearances for our auto standard connections. And then we have our composite reaction factors. So based on our nominal depth of the members, what is our RX factor? This allows you to set basically a percentage or a factor of what that composite design is going to be designed by. The next thing we're going to take a look at is our bolt, washers, and holes. To go back to our job settings, we can simply just click on Job. We can then select Bolts, Washers, and Holes. Inside of our bolts, washers, and holes, we're going to start by selecting our bolt settings. In here, we can specify for our AISC 13th edition bolt design, do we want to limit the state for our slip critical bolt design? Do we want that design as stated in J 3.8? Design all bolts with slip as a serviceability limit state, or design all bolts to prevent slip at the required strength level. Again, that does only apply to the 13th edition. For our default bolt class, do we want to make all bolts automatic, all of them be field bolts, or all of them be shop bolts? With that set to automatic, the system will go through and decide which should be field bolts and which should be shop bolts based off our project settings as well as the framing situations. What is our minimum bolt length? What is our minimum stick through? What is our maximum stick through? Do we want all imperial bolt lengths to be in 1/2 inch increments? For metric bolt lengths in 10 millimeter increments? Do we want to add washers to prevent shank out when needed? What is our maximum bolt gaps for our field bolt and our shop bolt? And then we can specify our available bolt diameters. We can use both imperial and metric within a project if we wanted. And then these are the bolt sizes that we want to specify to be allowed in this project. What is our hole allowances? Do we want that based on job units or bolt units? And then do we want hole diameters to match the primary units? So if we were using both imperial and metric for this project, for example, because we are using imperial units, if I used a metric bolt, the hole diameters, if this is checked, the hole diameters match primary units, would automatically convert that to imperial. If that is unchecked like it is now, then it would show on our detail in metric. Below we have our default bolt criteria. What is our default for our non-moment bolts, so our bolt diameter? And if I change this, I have the option to apply this to our auto standard connections. And then the same for the bolt type. What is our default type? And if I want to apply that to all auto standard connections or not. The default bolt size that is called out here is going to affect how our details are shown. Our non-standard hole sizes, so anything that is not a 13/16 hole because of the oversize here, will be called out. So if we wanted to see every single hole size, we could come in here and put like our default at 1/4 inch or something similar, and then when we detail our members, all of those hole sizes should be called out. We can specify our moment bolts, our vertical brace gusset to supported, or horizontal brace, the K-joist, KCS joist, LH joist, DLH, SLH joist, and our G-joist bolts, as well as our BG, VG, and CJ joists. Then we have our flush frame joist connections and our HSS welded brace erector bolts. So again, for any of those, we can specify the bolt diameter and the bolt type. Next, we have our bolt specifications. As you can see, this is for our 15th edition. If we're using a different edition or a different manual, this will result in different bolt types. But we have our bolt type, the material, the group, our connection method, the surface class, our shear F and V, our tension F and T, and then our nut grade values. If I wanted to, I could come in here and specify whatever type of bolt I wanted and give it any name. As long as I have all of these fields filled out, that will then be a usable bolt in the model. However, the values for our shear and our tension are going to affect how our calculations come out. So we will want to make sure that those values are correct. Next, we have our nut and washer schedule. We can specify our grade name and nut type. Our nut types, we have our heavy hex, heavy square, and jam nuts. And then in our washers, we can specify our grade name and the washer type. As you can see, we can specify a hardened washer, a flat washer, a bevel washer, a direct tension indicator or DTI, a square plate, a round plate, a hillside, or material plate washer. Next we have our washer settings. This is where we can define the default washers to use for each hole type in the different configurations. So based on a flat washer or a hardened washer, that's going to be our default thicknesses. We can then go in and specify by bolt type when we want to use what type of washer. So for standard holes, we can specify a primary or secondary under the head and under the nut. So we can specify based on the hole type what washer we want and how many. We then do have the checkbox for use tension control bolts. This is going to allow you to set your TC bolts for your job for both shop bolts and field bolts. If we take a look at our F18, 52N, SC, and X, we can see those are checked on by default, and no matter what we do, we cannot uncheck those. Same for the F2280 bolts. Next, we have our user slot lengths. When I come in here, this is going to allow the user to define a slot length based on the bolt diameters. So you have the option for a slot length number 1 and your slot length number 2. The default long slot and short slot values will not be affected by this. This is a completely separate user controlled slot length. I'll go back to my job settings and we'll take a look at our material grades. Inside of our material grades, this is where we can set up all of our default grade information for our different material types. So if I go into angles, we can see our grades are in here. And just like I said with the bolts earlier, the FY, FU, RY, and RT values are going to define how those calculations are generated. We do need to make sure those values are filled out and are accurate. The first line in here where it says default 1 will be the default grade used when adding those material types and will affect any material that is already added in the model. So you could always come in here, select whatever steel grade, and move up or move down to make those adjustments. So we have the option to control our angles, our cruciform materials, our channels, flat bars, grading, HSS/TS production standards, our HSS/TS grades, our pipe grades, plate grades, rebar grades, round and square bar, shear and threaded stud, our turnbuckle, clevis, and pin, our wide flange, and our WT. Next, we have modeling. And this is going to allow us to set up some general modeling settings. For example, our colors, our descriptions, our revisions, and some offsets. We can go in and set our job north. We can set up our zone and sequences. So for this, we are going to want to set up some zone and sequences. So go ahead and select that. And then for this project, we are going to have 4 sequences. So we need to change our maximum number of sequences from 1 to 4. And as soon as I select tab on the keyboard, we can then see our sequences updates to 4. And then once you have those 4 shown, we're going to hit sequence names. And for this project, we want to call this 1A, 2A, 3A, and 4A. Once I have that set, I can say OK. And with this, we can specify what zone houses which sequence. In this case, we're only going to use sequences since it is a smaller model. But if we were using a very large model that we would want to set up and send out differently, we could definitely do so. Once I have these 4 set up, I'm just going to go ahead and say OK. Next thing we're going to take a look at is I'm going to go to Job. And then we could come in and set up our custom properties. In this case, because it's our basic training, we won't have time to get into custom properties, but this is where we could go to set up custom properties for job, members, material, bolts, holes, and welds, and then activate any that are in there by default. And then we have our concrete and rebar, which we won't get into for this as well, but we can specify our concrete and rebar information.